Okay, I guess we'll get started here. Um, Welcome everyone. I see that we have a couple of new folks today. A folks. I thought I had. I was hoping some. There were a couple of new guys that were saying that they're going to come in and check out the study group. Welcome to today's episode. Of the Common Lisp Study Group. I hope you guys all enjoyed the Common Lisp Game Jam. Unfortunately, my limited day and a half, 2 days kind of experience on it was fun. Unfortunately, work kind of got in the way. Um, anyway, today we'll be talking about some interesting things that was brought in to the chapter 5 of Let Over Lambda that Doug Hoyt, the author, sort of brought up. One of the things is that we'll be discussing is uh, this concept called implicit context. The other thing that we'll be talking about is hopefully recursive expansions and solutions, which is dealt with in advanced when you're doing some advanced macro programming. And if time permits, because unfortunately that last two sections I hadn't had a chance to really go through and dig in. We'll talk about D Lambda and advanced closure programming, which allows you to essentially add like multiple methods inside of closure and do different ways of invoking those object methods. The first thing that we're going to get started though with is something that that I want to discuss. Especially given the fact that I'm hosting this on the Atlanta Functional Programming Meetup. That is whether or not Lisp is a functional language. Now, I know there's a lot of differing opinions on there. Doug Hoyt has a very strong opinion on Lisp not being a functional language, um, although it encourages a functional style. It gives you features that allow you to program in that style. I would argue, and I would agree with that approach that he was bringing up. But I want to at least set the stage for that discussion with kind of what we all agree on what a functional programming language is.
Well, it depends what you mean by functional, because like functional could be in the mathematical sense, where you take an input and you get a specific output, referential transparency. But Common Lisp is functional, but it is not, because it's multi-paradigm.
That's what I would say. It's a multi-paradigm language that of which functional is one of those styles. Um, but to call it a functional language is kind of dismissing other aspects of the system. It isn't just a functional language, just like it isn't just an object-oriented language, right? But you could do object-oriented programming, as we saw with the Common Lisp object system. You could do functional programming language, as we saw when we started talking about higher order functions, writing functions that map inputs to outputs, like this simple example. Let me just share my screen, because I just realized that folks here are not actually seeing what I'm typing. Here. So, if we have this dumb function that essentially, takes in a value and returns an increment of that value, if we describe this guy as was taught shown in the book, at least with SBCL, we will see that, it is a function type. It specifically, SBCL will also tell you that it's been compiled. Um, for folks who are looking at other Lisps, you may not get some of this other information. You might get the Lambda list. I don't think you would get like the derived type in other languages. In other Lisps. I may be wrong. Allegro and some of the commercial Lisps might give you this type information. The bottom line is it created essentially a lexical context, and the book calls it a procedure Although I have a very different definition of what's considered a procedure coming from Pascal. It's just like, a void a void function that, does nothing. I mean, you have steps. It'll go and, run and execute instructions, but at the end it will not return a value to you. It won't. It'll just be void. In this case, obviously, and again, this goes back to my first language being Pascal. There was a clear distinction between what's considered to be a procedure and a function. Um, Lisp, in many ways, is kind of like C in that, a void function is still defined with defun, um, uh, but that's considered a procedure to me. It's not returning anything. But even the cases where it does return something, Lisp gives you the ability to, define a function that returns different values each time it's instantiated, even with the values that are passed in. Uh, the term that he used, though, I've never heard. He calls it a fun callable instance, and he says that it comes from art of meta object programming, which is why I was kind of curious if other folks on this group has seen that term used.
That's a fun word. Yeah. So a fun callable instance is a class which subclasses is an instance of a class that subclasses from a function. That's probably the simplest way to describe it.
Okay. So anything that subclasses from function is fun callable by default. But is function itself a subclass of anything other than object?
It's a subclass of T.
T. Okay.
But everything's a subclass of T.
Right. T is the universal.
Yeah. T sits at the top of the object hierarchy.
Right. T is the top of the object. Yeah, you're right.
Well, the T class is the top of the object hierarchy. That's important.
Right.
Because T, the symbol, is a bool. And a symbol.
Right.
But T, the class, is the top of the object hierarchy. A fun callable instance is a bit weird. Because you basically cheat, is probably the simplest way of putting it. What you do when you make a fun callable instance that isn't just a regular function, a regular lambda,
yeah,
or a defun or something along those lines, is you, in your initialize instance method, you have to call this special function set fun callable instance function. And basically you give it your instance and a function. And what will happen is if your instance ever gets called like it's a function, what will actually happen is that function that you set will get called. And you can change that at a later time. At any time you can change what the fun callable instance function of your object is. And that just changes what function gets called when your object gets called as if it were a function.
Okay.
So basically a fun callable instance is anything you can fun call. That's really what he means.
So is it like a callable in Python?
Yep.
Okay.
That's the simplest way of putting it.
All right. So I just wanted to make sure that because we haven't talked about the meta object protocol in Lisp really.
Not really, no.
So that term kind of threw me off. I was like, okay, I don't remember this, but it's something that...
Yeah, funcallable instance, if you're not worried about the meta object protocol, you can just say function.
Okay.
But if you are worried about the meta object protocol, you have to be a bit more broad, and you have to say funcallable instance, because a funcallable instance really means anything that can be funcalled.
Okay. All right.
Because everything's an instance.
Yeah, right. Everything is an instance. That's the reason why I was like, okay, so the real key term is funcallable. So is the class name funcallable, or is it something else?
Instance.
The instance is funcallable, but the class is function.
The class is a function or a subclass of function.
Subclass of function. Right. Okay. All right.
Yep. The function and its subclasses are all funcallable.
Right. Okay. The other thing that he brought up regards to at least a functional style is, and this is probably more important than anything else that he kind of said in that section, in my opinion, but, feel free to, disagree with me, is what the notion of functional programming really brings up. And this is something that we've been trying to kind of promote, at least I have, which is try to make the majority of your system has what's the word, immutable as possible, and separate those non-functional parts from what actually can be functional. So that way it's easier to at least manage the kind of like the separation of concerns in such a way that you could leverage a lot of the advantages of referential transparency and the features of the functional style where it really is appropriate, like, for example, concurrency and parallelization, those kinds of situations. But the fact that he kept on digging into it and then doesn't say that, well, I would actually put this in the camp of like Haskell and OCaml. I was like, kind of like, what? Okay. That's interesting to bring up.
I don't like calling Common Lisp functional, if only because, Common Lisp's killer app is class, and everything is an instance. Everything is an object in Common Lisp. So it's very, very difficult not to work in an object-oriented sense, even if, you're just using generic functions.
Yeah, but the nice, I thought, when I really started getting into Common Lisp, and again, this is before I started learning other functional programming languages, I thought the killer app was the fact that I had the ability to create these higher order functions that I could simply customize based on particular use cases. That technique, up until recently, was difficult to, although it was possible to do in other systems languages like C++, it just required a lot more work to actually go and do what the Lambda abstraction provided for you for free inside Common Lisp. And again, this is before I learned other languages that supported the notion. Common Lisp, in my opinion, has the more efficient version of creating high order functions, but that's just my personal bias from playing around with it over the years. So it kind of influenced my thinking, so to speak. So let's get started on this other thing, and this is a bigger topic of discussion, and the majority, we're going to be spending some time on it. In Chapter 5, we talked, he brought up our old unit of time macro here, as you can see here that I, kind of brought up. And he said that, well, this is a kind of useful macro. What we really want to be able to do is, have a way of defining these kinds of units in terms of each other, so to speak. So, like his example was, I think it was def units time s, where your default was set to s is your base unit. So everything below it would be, immediately below it would be defined in terms of the base unit. So like you can actually write, 60 here, and it means that 1 minute is equal to 60 seconds. You can say now 60 is now, at 1 hour is equal to 60 minutes, and so forth. And you could keep going up here, 1 day is 24 hours. 1 millisecond is 1/1000 of a second, and so on. So he went through the construction of a macro that ultimately generates unit of time. So by typing it like this, we'd end up getting unit of time, and we could say 1 day, and it will return 24 by 60 by 60 by 1. So this ultimately will evaluate down to, how many seconds are in 24 hours, given seconds being the base unit. Now, the example that he gave uses his def macro bang notation, which kind of was throwing me off because he also introduces the nested back quote. So I was kind of curious if folks here would be willing to uh, or would be interested in seeing this actually written in standard Common Lisp, which is
Well,
not
he's using a nested backquote. There's not a whole lot you can do to avoid the nested backquote apart from not using backquote for the nested lists.
Oh, I agree. I agree. His usage of the
but-
nested backquote. It's just that it also
But yeah.
hides the other stuff with that def macro bang, right? Because that def macro bang does your unwanted capture gensim generation.
Yeah, sure.
So that's
You don't need to use his bang macros. I implemented the whole book using just regular with gensims and once only. That's just his style. He wants the automatic gensims, but you don't have to do it to implement all the stuff in his book. If it's more easier for you to understand doing it the traditional way, then go for it. You're not going to lose anything from reading that book.
right, and that's where I'm still getting used to his notation and mapping it to the with gensims. So I was trying to macro expand it into something that I could then generate the equivalent. So like if we started with def macro def units, bang here, and I think his was quantity base unit rest units. Okay. Here, I think at this point, first off, I forgot that I have to also, in my Lisp image, include Alexandria so I could get with gensims.
Body, not rest.
Sorry, his book keeps saying rest, and it's kind of throwing me off.
Yeah, that makes no sense to me, but oh well.
I'm just telling it like it is, man.
Yeah.
I understand your frustration, but that's also my frustration of using the bang macros because it keeps throwing me off when I'm reading his code.
As a side note, packaged local nicknames are officially in CCL now.
Packaged local nicknames. Okay, is that the same syntax as packaged local nicknames in SBCL?
SBCL and ECL and ABCL.
Oh, sweet. Okay, so we're getting close to full portability.
Yep. Yes.
That's good news.
I bring it up because I almost always alias Alexandria as A in my CL user package because I find it makes writing short examples like this a lot faster.
Okay. How do I do that?
New thingy called local nicknames. In your def package. :local dash nicknames. And then in parens, :A space :Alexandria. And recompile that.
Okay. And
Yep,
let me
nice.
change my package here. Alright.
Yep, and now you can say A with gensims.
Okay. So he has in his book Gval and Gunit, which I've been trying to figure out what the. So for context for folks, if you guys don't have the book, I'll give you some context here. I actually have. He was kind enough to actually offering Chapter 5 in its entirety in Chrome. So let me just go and share that screen with you folks. Thank you, Doug, for giving us the opportunity to at least see your book there. Let me just change this to Lambda. Okay. And share my screen with you folks. Okay. So in here, if you go down to where he defines the def unit, I guess we could just review this in a little bit. He basically has this gbang val and gbang un. I'm assuming that when we convert this into witgen sims, I just need to say val and un, and then I can use this nested backload structure as is. But I might be wrong.
Yes, his def macro bang there just interprets the gbangs as wrapping a with gensims around the body.
Sweet.
So if you do with gensims val un, that'll be the same thing.
Excellent. So let me go and show you guys that for folks who are following me along on the stream. At this point, if you guys who are on the stream have any questions, feel free to ask them while I type some of this stuff out. Oh yeah, I have to share my screen on my Hangout too. All right. Val UN. Just and I'm hoping that I don't have to change anything else other than that. Give me a few seconds here. My apologies for folks who are like, what is he doing? Okay.
You don't want to do that.
You missed the nested def macro.
Did I? Oh, I did miss it, didn't I? Yeah, that's right. Thank you.
You also typoed quantity with a T.
It's one of the reasons why live coding is always a difficult one too. I constantly. My apologies, folks, who are watching this.
Oh, you're good. I just,
Does Alexandria have the sim function that Paul Graham wrote that generates new symbols?
Yes, it's called symbolicate.
Okay. Symbolicate. Okay. Oops. Now. Miss any other parentheses here? No, I did not. Okay. Now. Okay. Has what's it? Sly updated to a new version where they fixed this autocomplete issue, because I haven't updated in a while. I noticed that I periodically get these wrong autocompletions.
Yes, Elijah, I remember that issue. It's a SpaceMax thing, or configuration thereof.
It's a SpaceMax thing?
But the Sly layer is currently broken, so I don't recommend trying to update.
Oh, great. Okay.
Yeah, that's in part on me. I just haven't found the time to go in and fix the issue.
Alright.
I don't run SpaceMax anymore, so bug fixing things in it requires that I swap back out my SpaceMax config and start testing stuff and figuring out what they've changed about the codebase again and stuff.
Oh, you went back to just pure Emacs?
Actually, now I have, but for a while I switched over to Doom.
What's Doom?
Doom.
Oh.
It's another distribution. It's based on Evil as well.
Oh, okay.
It also has a Sly layer. Well, module. They call it a module.
That I again wrote.
Sly by default. What was that, Michael?
I said that I yet again wrote.
Exactly, yeah. But you're still using Doom, aren't you?
No, I mentioned last week that I switched over to a straight .el.
That's right. Yeah, so neither of us are actually using any of the prepackaged Emacs anymore. Oh well.
I need to go back to. At one point, I had a VI setup that worked really well for me. That I kind of missed. It was very simple, but it uses screen a lot. I ended up just using screen and separating between my Emacs, my VI buffers, and then the REPL. But Slime kind of ruined me a little bit. Oh, group.
What are you trying to do there with group? It's not an Alexandria function.
It's group is basically taking the units. I might be. I may not need this, but this code uses.
Where is group defined?
I thought group was in Alexandria. That's why I used Alexandria.
No, it's not. If you look at your buffer below, it says it's not.
Yes, that's why I realized that.
What does it do?
Group basically flattens and he defined it in, I think, chapter 3, where it flattens and groups things.
Oh, I know exactly what you want. I know exactly what you want.
You want pairs, right?
Yeah, it's a function in Serapium.
Yeah, that's what I was thinking.
Yeah, give me 2 seconds. I have it in my utility library right here. Let me pull that up.
I didn't want to go and rewrite group, but I guess I could.
Yeah, no need. Just pull in Serapium.
Okay.
Add a nickname for it as S. That's what I usually do.
Okay.
And we'll tell you the function that you want in just a moment.
Do I just do S Serapium?
It's called batches.
Oh yes, that's right.
It's called batches. Okay.
Yep. So S : batches.
And that's the same thing as Paul Graham's group.
Serapium. Please load. I've noticed that I was getting some weird loading issues with my Lisp earlier today. It kind of concerned me a little bit. Oh shoot! Let me just do this. Okay.
So I do have this this macro wrote already with if you can't do it and get stuck, I do have it written already for without his gensim being whatever.
It looks like it compiled. So this first one, I think we got. Hold on 1 second. Let me just close this window, and let's go through this one at a time. Now, when this took me a little bit of time to actually get used to it. So new macro developers will. I'm assuming I tend to be pretty slower than most people, but to debug a macro and to read through a macro, especially when it comes to nested quotes, you need to start essentially. I always wrote down it by hand on a paper and labeling what level the quotes are in, but that's just me. So the idea is each nested quote will take you up one level in terms of code generation. So like this first nested quote, let's call this level 1, all right? And I'm going to probably end up, or level 0 using C, since I can do C-style indexing here. At level 0, this code gets generated. These unquote operations will execute this expression, which will create unit of, and whatever's passed in quantity. In our case, it'll be unit of time. And it will. Did I miss one thing? No, I didn't. Okay. And it will also pass in this the unquoted val and unit gensims. At this point, we're now, when we create another nested quote, we're now at level 1. So everything above that hasn't been, that's only getting quoted once, will won't be completely evaluated. It'll be only going down a level to whatever evaluation level it was given in the previous version. So in here, what we did is we unquote. If we just left this as this will only give us the gensim. But since we're quoting it twice, it's actually going to give us the value of the value inside that was generated by with gensims. Correct me if I'm wrong here, Elijah or Michael. But my understanding of this is this two unquoting operations means you're going down the level and actually getting the value that was created when you pass.
That's correct.
Okay.
Yep, more or less.
So the same thing here. You're not actually getting the value that of the with gensim. You're actually only getting the gensim here. Same as the base unit and all the other ones, because these were defined earlier on inside the macro. Now, question 1 that I had when I was looking at this code, and this is a point of discussion for folks, is since this def macro base unit was passed in as an argument, is this unquoting forcing it to get the evaluation, the actual evaluation? Is this at the same level as this top level net quote, or should this actually be that?
No, because you're already back quoting the case. The whole case statement is evaluated at that level.
Okay, so we already did this once, so this is not necessary. But if this was like this, then we would have to.
Well, that would cause problems in other ways. But
yes.
Yes. No, I understand the I've changed the semantics of the macro, but I was just curious as to how the quoting process went. So if you
in fact, you can actually simplify that just a tiny bit. Doug has a habit of using the alternate case syntax, which is a list of values to match. You can remove the wrapped parens around base unit. That doesn't need to be there because there's only one value.
Okay.
I mean, that'll help a little bit anyway.
Interesting.
Same with the Lambda there. You're also have an extra level of nesting that you don't need.
Wait, the Lambda?
Yeah, you see the comma there?
Oh, yes.
The parens surrounding that? Yeah, you can remove the parens immediately surrounding that, yeah.
Okay.
Yep.
I think that's it. Yep, that's it. Cool. Alright, so let me just go and compile this. This kind of works, so let's see what happens when I do a macro expansion.
You're 0 and 1 there. Get rid of those. I don't think they're going to cause problems, but...
Oh, yes, of course.
I don't think those will cause problems, but at the same time, I never trust code with annotations.
Okay, so we do a macro expansion of this guy. Where is
S?
Sorry, I have to
S.
Oh, okay. S, not X, comma MSF.
E.
Oh,
E.
E. What the heck?
Hit C. Hit collapse. Hit C. C.
Okay.
Just hit E once.
There we go.
There you go.
So, this... Oh, well, first off, I messed up here. So I just realized that it's not exactly identical, but that's not a big deal. I just need to add that. Now, this will be exactly identical to
I posted a link in the chat for the next part where he changed them.
Ah, cool.
My implementation of it.
Perfect. Let me go grab that from the Hangouts.
Where you appear to not be using package prefixes for things.
This is in my utility library, Elijah. I import 6 Serapeum in Alexandria.
It's actually in your utility library.
Yes, you can look at golden utils for the same code.
You have def units as a part of your utility library.
Yes, I do.
Oh, okay, fair enough.
He is.
If this is actually a part of the code in your utility library, that's fair.
Yes, it is.
Shame on you.
There was a couple of instances where I needed it, so I stuck it in there.
Oh, jeez.
Yeah, that's fair.
Okay.
It's just a little confusing reading it as a pulled-out snippet because you have places where you're referencing Serapeum without a prefix.
Oh, I'll go edit that for you, Elijah.
Now, folks who are looking at this, you might have noticed in the expansion that we now have, and for completeness sake, I really should show the original code here, which is in my different buffer. Give me a second here. Why is it taking its sweet time? I love Space Mac sometimes. It just...
What are you waiting for?
I hit tab and now it's
Oh, yeah, no. I almost never switch buffers that way.
Space Max kind of now
you got an X command waiting to be finished there in your mini buffer.
I haven't.
Well, he's trying to tab complete it.
Oh.
And
yeah, just use space BB, man. Just use space BB.
Space BB.
Yes.
Thank you. I didn't. I'm just so not used to. Okay. So if we go back to our original here, now obviously for folks who haven't seen this code, this little generated code, the def units percent side has more units than this one, but it does essentially the same thing, as you can see right here. It generates essentially the same kind of template, where it will compute how many, based on the base unit seconds, of course, what ultimately we did in the previous discussion on units of time. But there's more. You can actually go through with this and add things like chaining. Chaining was the idea of the fact that and this is what we need for this in order to be complete, which is as you noticed here, what I'm doing is chaining. I'm taking the previous notation and I'm adding the units of the previous units as being the base for the next units. Now, the way you would do this, and Michael was kind enough to actually write this code, so let me just share my screen for folks here. Give me just 1 second.
You're just missing a couple packet qualifiers, as Elisha pointed out.
Of course.
That shouldn't
give me just one second here so I can actually stop screen share. Change this over to units.lisp and display it, and for folks on the chat. Okay. So in this code, the best way to handle this is, as you may notice, this will be a recursive function, because since everything is defined in terms of something that was previously defined to it, you can keep recursing through the structure until you find what you want, and if you can't find it, it'll spit out an error. So with error checking, and I'm actually kind of glad, by the way, Michael, that you use when here, because I was wondering why you didn't use when he wrote it.
Yeah, he uses if for every case of when. I'm not sure why.
Yeah.
Which I don't like because it has, it throws off the indentation, and then you're looking for the else clause. And
yeah, I kept going. Why not use when? What is your, it just doesn't make any sense. But in his def chaining, if you can look at this, we basically start with what we're looking for, the units, the list specifically, and we grab the where is it? It's we grab the units in the list that's passed in has a second argument. Check to see if it's a member. If it's been defined, we define a chain to say, okay, let's compute the actual value of this unit by taking the car of the chain, which contains the actual original value, and it will multiply that value with the recursive call. So it has to keep looking up, well, what is this unit defined as? What is that unit defined as? To take an example, let's say that you were looking for 1 hour, okay, and seeing how many seconds you would get. So what you passed in here is 1 hour. Clearly, it's not a member at this point because we are still building up the table. So you find the units that it has by first saying, okay, let's grab the car of this, which is 60, and you then say, hey, is this a sublist? If it is, we're going to multiply 60 by whatever minutes is defined as. So you now have gone into this list and did another lookup. And you keep going until you find the base unit, which is seconds. And once you do, it will go back up the tree, and it'll return 60 by 60 by 1, which is 3600, which is equal to, 1 hour is 3600 seconds. So this, I encourage folks to actually hand execute this just to see what it does. That's how I at least figured out how it was doing its thing. But then def units is pretty simple. All it does is it defines your base unit for us, okay, has 1, and then it takes in this def unit and an initial list where the base unit is first defined as 1, and then you start grabbing the rest of the subunits in batches, and then you return the batches of the units here. Let's see how this actually expands. I'm going to go ahead and copy this into my buffer for completeness sake, and then we'll go back and try that again. Just give me a second here. Let's go back to Emacs. And share my screen with Emacs. Okay. So here is our def chaining, Michael Piano's def chaining implementation, and obviously I'm going to have to...
3 changes to make to that.
Yeah.
And symbolically, we fix that, and the 2 batches. We fix them. A, and then S for the 2 batches.
Yeah,
and that should do it.
So for folks who are wondering what these changes are, batches and symbolicate are in two different libraries. Symbolicate is part of the Alexandria library, and it is the equivalent to Paul Graham's sim function that's defined on Lisp. That's actually what's being used in Doug Hoyt's book. And batches is the equivalent to Paul Graham's group that's in his book as well. So let's go back to our example here, which is def units times. And let's just change this to use def units now. Okay? If we macro expand this, oops, wrong one. Hold on. Comma MSE. That's it. You could see now that this defined our function, and it has gone through and just quickly computed the actual constant values, and will return these constants as a simple lookup based on the case that's being passed in. But let's say that we used, and this is the real thing, let's create a dummy example here, which is the example that he used, which is def units times second, where we define minutes in terms of hours and hours in terms of minutes. Let's see what happens when we compile this guy. You will see now that what we've done is we've actually found the cyclic dependency because it looked up and recognized that there's a dependency on a previously defined value that wasn't defined. Like hours wasn't defined until later, and then minutes wasn't defined. So it basically recognized this cycle and spits out this very nice error message. Now, you might be thinking, well, okay, this is great. We're creating units of time. We're having this quick lookup. What's the big deal? Recently, this can be used to even go further to define what could be considered like units of measure that's being used in languages like, say, C#. You can actually create the system that does that kind of checking for you and and provide proper error checking just simply by creating the macro to generate those functions and do that checking for you.
I wouldn't actually use it for defining, like, for having a long chain and defining something with a floating point, because floating point accumulation error will introduce, and yeah, it could be.
Well, it's funny you brought that up, because that is one thing that Doug seems to, and I wanted to know people's thoughts on this. He seems to believe that by taking this approach, you could postpone having to deal with some of those approximation issues until much later. And you can leverage, based on, of course, how you define your constants, exact arithmetic as far as possible, and then you can always coerce it to using metric approximation if you want to use it for floats. But I do agree. I think
you said every time you accumulate a float, and which you could be doing multiple times in a chaining macro like this,
yes,
you're introducing error, and it's just going to be a little bit off, and then even more off the next chain, and so on and so on. So that might not be what you want, depending on your accuracy.
Right.
Well, as long as the constants you're using inside the def units themselves are either integral or rational.
Right. I'm just saying with floats, it could be, with every level of the chain, it could throw it off more and more.
Right. But that's the bane of using floating in a sense. Like you're not bringing that error with you if you and if you're not too careful, it'll make your your results just significantly different, right? I mean, that's just one of the reasons why you always end up trying to leverage the largest floating point representation that you can, so that the error is accounted for as far as you can based on what types you're using. That's why C actually does that kind of that implicit promotion. Although it could throw you off if you're not too careful, from single floating point precision to double, and back to the single. But Lisp for the most part uses we talked about this, I think. It has 32-bit precision floats as well as 64-bit precision floats, right? Um, it does
Well,
single
SBCL
precision
does.
32. SBCL does. Okay.
Yeah.
So.
Yeah. Strictly speaking, the common Lisp spec allows for floats to be defined pretty much however the heck the implementation wants them to be. It doesn't even have to be base 2. There are actually functions for looking up all that information, like what the current radix is for your float implementation, what the size of the mantissa and the exponent, and all that stuff. You can inspect on all that stuff at runtime, but it's all implementation defined.
Right, it's not implemented with IEEE 754, but most implementations are.
Yeah, and actually, if your implementation does use IEEE 754,
754.
754 is
then it's in your features list. That's actually guaranteed by the spec. The spec specifically states that if IEEE 754 is in your features list, that means that your implementation, I believe the wording they use is, purports to conform to the IEEE floating point spec. So implementations, that one's one of the standard features. There's like 5 standard features, and all the other ones are completely implementation defined.
okay.
Interesting side note, I feel like would be useful to bring up. The most recent SBCL release, SBCL 1.5.2, Baggers actually brought this up on his stream on Wednesday, has added a new number syntax.
Really?
The spec actually specifies that implementations are allowed to define their own extensions to the floating point number syntax, or they're basically their own definitions for what the letters mean, right? So you have, D is for for single floats, and E is for your default float format. But actually, the spec specifically says that any of the other letters are fair game for the implementation to define as valid float syntax. And SBCL has just added one for R, which actually defines the rational number, which when converted to float would produce the float that you entered. So it's a way of entering rational numbers using float syntax instead of as a fraction.
I'm still not convinced that's a great idea, but
Well, so that is useful if you it's just another way of writing rationals if you already have the decimal representation that you need.
Right.
Right. So like if you're talking about 3/10 versus 0.3, right? Which is if you're porting code from other languages, 3/10 would just get translated to 0.3, right? So that way your math doesn't have to deal with floating point error, right? Because internally everything's represented as rationals, but the
Right.
numbers you're typing are using floats.
Oh, okay, I see. It's the other way around. You're saying that the floating point is more of a lookup to the rational equivalent.
Correct.
Okay.
You type a floating point number, it constructs a rational number that would hold the same value as your float if you converted it back into a float.
Got it. Okay.
But internally it represents as rational.
Yeah, that actually helps because that makes the arithmetic more exact. And you don't have
so
to deal with
that's the R suffix.
Yeah.
So you can do on the very latest SBCL 1.5.2, you can do 1.0R5.
1.0R5. 1 second. Now I'm kind of curious. What do I have? R?
You don't have that
No,
one.
I have
It was
1.4.
released, It was like released a few days ago or something along those lines.
Yeah, which means
Or like
Roswell
last
probably
week,
doesn't
maybe.
have it yet. Um,
Yeah.
yeah.
Heck, I'm not even running it yet.
Oh, that's pretty cool. That actually really would help in some data
Yep.
analysis cases.
Yep.
Um,
If you're specifically using SBCL.
of course.
Roswell does have it already.
Roswell. Oh, it does. Okay, so that means
Yeah, they're pretty. I mean, they just track the latest Git release, so.
yeah, I need to go and install. Yeah, the latest version I have is 1.4.6 or 1.4.16, something like that. So
But I would urge you not to use things like that if you care about portability. If you want your code to run on CCL or whatever else.
right. So really, what we need to do is push other people to incorporate some of that into their list.
Well, I mean that's true all over the place. I mean that's why like atomic operations are slowly expanding from different implementations, and eventually portability library. Well, in this particular case, portability library for float syntax won't happen because the extensibility just isn't there. But I mean this is the way progress happens.
Yeah,
You know, one
look.
implementation does something, and then the other implementations are like, okay, that'd be cool, and oh look, there's some code out there that's already been written to use it, and clearly it's nice. And
Well, I'm hoping someday, but this might be a dream in the future, that we will eventually see SBCL user-defined sequences in the rest of the Lisp
yeah,
ecosystem.
maybe.
Well, it could be worse. I mean, we could be using something, like, I don't know, some other language where, we have to rewrite all our code whenever a new version is released.
Right. So let me go here. Give me this one
List
second.
world problems.
Let me just abort this because that was a clear mistake. All right. So our next topic is going to be. Now he calls this a technique, but I don't know necessarily if it's per se a technique. But I'll give you the context. You wouldn't happen to have the tree leaves example in your repo now, would you?
I very may. Hold on a sec.
I'm going to go ahead and start with this example. Let's say that what you are building is you have
Yes,
a tree.
I do.
Oh, you do. Sweet. Okay, so I'm going to grab the results of that once I give this simple one here. So let's say that you have a tree and you want to change.
Oh, the basic code walker. Okay.
Yes, yeah. The basic code walker.
Which only works for changing symbols, not arbitrary, branches.
Right. But that's fine because later on he uses this to kind of introduce us to macrolet. So, and for folks listening, pay attention. It's macrolet, not macrolay like Chevrolet. Right? It's macrolet. Macrolay like Chevrolet.
Oh yeah, no.
I'm just saying it's not. Anybody who says that it's macrolay is.
I've never heard that before.
It's definitely not symbol macrolet.
It's not symbol macrolet. It's just macrolet. Because he says that the use case that he's thinking of is essentially the case where you are I think you are binding a particular sub macro in based on a particular context, and so rather than defining a macro and then creating a separate lexical context for that, you could just use a macrolet to generate that code for you. At least that's the way I understood it. I'm not entirely sure if I'm explaining it correctly.
Link in the chat.
What? Oh.
Link to the code that you wanted pasted in the chat.
Saw it. Excellent. So the case for this is so first let's talk about what is an implicit context. The way he describes it um, is we sometimes choose to have code around particular portions of an expressions, um, so that we don't have to write it every time by use of an abstraction. Now, in earlier conversations when we're going through this book, I think it was brought up that what an implicit context is. For example, when we talked about closures and closure-oriented programming, Lat and Lambda forms, what they do is they create what's called an implicit prog-n. And by prog-n is a special form that allow you to run multiple Lisp statements in sequence. Um, Let and Lambda allow you to do that without having to explicitly write it down. Uh, just like that, defun is an example that generates an implicit lambda for you, so you don't need to actually use lambda when you're defining named functions. Although, as a side note, for folks coming from Scheme and Racket, define square x has a lambda. For me, it looks a little cleaner, but that's just because it looks like, just let a generic let form. But that's, you know neither here nor there. But it's the same idea. Instead of doing that define kind of syntax, defun already does it for you behind the scenes, so you don't have to actually worry about that. Tree leaves, as I wrote here, is a simple example of what we call a code walker. As all you know, when you get a Lisp expression, you could think of a Lisp form or Lisp program has a representation of a AST or a CST, depending upon who you talk to. And this function, this tree leaf function, is very simple. It just goes through and walks through the car and cater of the tree until we hit the leaves, and then it will spit out. But what this does is it actually, I think I messed up one thing, which is I forgot to put the base case. Okay, that's right. So what this does is it will loop through the tree when it gets called, and it will add whatever the value of the result into that tree if it finds a leaf. So let's take, for example, I think I should have to do this, yeah. Print tree leaves. We take in a tree, a very simple tree that has a couple of subtrees, and we return leaf. So anytime it visits the leaf, instead of actually returning the value at that tree, it will actually just go ahead and return leaf instead. So when we run this, hold on 1 second, did I mess something up here? Not a typed list, that's a quoted list. That should not have...
Okay. So, run that.
Okay.
That again, yeah. In the debugger. Go into the debugger. And hit Shift V.
Shift V?
Shift V.
Shift V.
Which one is it? Oh, no, it's just regular V, isn't it? It's just V. There we are. Yeah.
Line 67.
So what it just did was it jumped to your cursor to the exact spot where the call happened and triggered the error.
Okay.
So you're passing in 2 as the tree, which probably means you need it to be a list.
Yeah. I'm an idiot. I actually forgot one thing. I miswrote this code. So I have to take this guy in the cons. Yeah, I have to wrap this guy and say if this is a list. Lisp tree. Not Lisp. Lisp tree. Oh, jeez. And I think result actually is supposed to go in here. Yeah, that's the reason why. Oh, wait, I should have slurped that. That's space K, slurp.
S.
S. Yeah, that's right. That's what I needed. Let me try that again. Alright. So what this did is it went through, check to see if tree is null. If tree is null, it doesn't do anything. Actually, technically, we could change this because I think this should be when tree. But, you know,
Oh yeah. And then you want to. No, it should be if. It should be if, but then you want an else branch to return the if list p. So yeah, you probably want to return the car of the tree, right?
I think so, but I don't think you need to do that. You could do it because right now it's actually working as designed.
Because in that else case, tree is nil.
Yeah. So this could be just a when, couldn't it?
I mean, that'll be the same behavior. I don't know if it's the behavior you're looking for. But
yeah, that's what I'm wondering. Okay.
Oh, good. Yeah, this should work the same way. Let's see. Yeah, gave us the same results. His use of if all over the place. Alright. So what this does is it checks to see if the tree is nil. If it's nil, it doesn't, it spits out. But if it is a list, it will go ahead and walk through the tree by calling the recursive call on its subtrees with the result until again it hits a leaf. When it hits a leaf, it just returns whatever the result was. In this case, we passed in a leaf. This is probably the simplest code walker you could literally write. It obviously doesn't do everything, but it is very, very simple in that it will visit every leaf in your tree. Now, based on what we really want to do, we don't necessarily want to actually just change every element to some particular value. What we want to do is transform the element based on some condition. That's essentially what Doug was trying to get at. Although I will say this, for folks who are reading Chapter 5 and wondering why he used why he used plugins instead of just saying high order function, kind of like threw me off, and because I was like, well, I guess you could call it a plugin. It's an illustration of the template pattern, but it's just really just a high order function. So the basic idea is the easiest way and most straightforward way to write these kinds of transforming functions is to allow a function to take in a function as an argument and use that function to transform as it's walking through. So an example of this is what he used, which was what's it? It's called it's just sort, really. In sort, you pass in some nonsense, some random list, 1, 2, 4, 3, and a predicate. In this case, we'll just do that. And if you run this function in your REPL, you'll see that it will call in the function and then just use that predicate to has the value to do the ordering. And
it might be worth mentioning that sort is destructive. If you let down that literal list, it would have modified that permanently.
Yes, that's true. It is it's an in-place sort, but I did not do that. I guess I could do that and show that off. actually, let T be this list. And
Well, sort's not in place for lists.
it's not in place for lists?
Nope, it's just destructive.
Yeah.
By moving the cutter pointers around, not by actually moving the elements.
Oh, okay, so it's not actually destroying the list, it's just,
Oh no, it destroys the list. It completely screws up the pointers to the other con cells.
yeah. But that's...
But it, yeah.
What were you saying then about lists, and it's not destructive for lists?
It's not in place, it's destructive.
It's not in place. Okay, got it. Okay. So you're saying that it's not changing the values around, it's changing the memory addresses, it's changing the pointers between the...
It's reordering the con cells, it's not reordering the elements.
Got it.
Which means that since you're still holding a pointer to what used to be the head of the list, that con cell may now have been moved somewhere into the middle of the list, and now you won't have a reference to the con cells in front of it anymore. The only way to get that reference is to take the return value from sort.
Got it. Got it.
Now, that's not strictly guaranteed. There may be implementations where sort actually is in place for lists. It's just not guaranteed to be, because there are sorting algorithms for lists that work by just moving the pointers around.
Actually, that will be pretty efficient. You don't need to actually change the values necessarily. At least with lists, you could just simply do it with pointers.
Which reminds me, there's a chapter in LLL on optimization.
Yes.
Or no, was it? I don't know. One of the later chapters where he actually gets into writing sorting networks for highly optimized sorting algorithms.
Yes, that's in chapter 8.
Yep.
I read a little bit into that.
Yeah, that's anywhere I've read, so.
Yeah, well.
I'll have to explain that one to me.
The chapter 6, by the way, is actually available for anaphoric macros. He just posted it, I think. Because originally only the first 5 chapters were available of Let over Lambda when I last time checked it. But now
I believe it's 6 now.
It's 6. 6 is available. I didn't really. I was like, whoa, 6 is available in its entirety. That's pretty nice.
By the way, if you want to see a function similar to tree leaves,
yes.
There's actually a function in Alexandria you can jump to definition at and look at.
Okay, what is it?
Flatten.
Flatten. Okay.
That does the same traversal, pretty much the same algorithm.
And actually the spec has a similar function as well. It's just no one remembers it. Because it's a little different. Subst.
Well, let's...
GD, I think?
I tried to do a meta period. It should actually jump me to the code, but it's not for some reason.
Only if your alt dot doesn't work in normal state for evil.
Oh,
to be an input state.
Got it.
You want to use comma GD.
I think it's GG actually, and
oh yeah, comma
GG.
That sounds right.
Flatten tree.
Double G.
Comma G. Oh, not F. Sorry. Comma GG. There you go. Flatten. There you go.
Yeah. Simple recursive function.
So what this does is you create an empty list. Okay. Then I love this. Sometimes I'm never sure if I'm reading the function list or a variable list here. Okay, so he creates an empty list, then he traverses true. When it's a subtree, traverse true and push the subtree onto list. Okay, I see what it did.
But pretty much exactly the same code.
Yeah.
It's just collecting the leaves into a new list.
Yeah, it's the only destructive operation in that area is n reverse, but since that n reverse is on a new list, it doesn't really matter. So,
Right.
wow, that's very very clean. So he brings this. I don't think I need to review higher order functions again because we've talked about it multiple times on this chat. But the one thing I wanted to at least talk about is his definition of function composition, because he says in his book, the concept of taking a function to control behavior is especially convenient because we can create anonymous functions suited to the task at hand, or when we need even more power, we can create functions that create these anonymous functions, which is known as function composition. That's not function composition, right? Function composition is you are creating a function, but the composition is just the semantics, right? It's the right to left evaluation
it depends
of.
who you ask.
Yeah.
It depends who you ask.
Yeah, really. Yeah.
If you're talking to a mathematician, function composition is as you describe. It's you take like 2 or 3 functions and you combine them into one function by taking the output of one and feeding into the input of the next, and the output of that and feeding into the input of the next, and such.
Okay.
Right. That's mathematical function composition. But he's saying that basically any time that you have a function that returns a function for this kind of purpose, he's calling function composition, which I find a bit of an abuse of terminology. But
thank you. All right.
You can play around with. There's a function in Alexandria called compose for doing exactly that.
Yeah, and that actually, I remember that. That's
It's also really inefficient.
what the way
Alexandria's composed.
Oh, right.
It's stupidly inefficient. It kind of has to be.
Oh, because of the currying?
Yeah.
Yeah.
Whoa, there's a defined compiler macro in Alexandria for compose?
Oh yeah. It's trying to be as efficient as it can be, but there's not a whole lot it can do because it needs to deal with all kinds of nonsense.
Interesting. All right.
Cool.
I almost never use compose like that. I almost always will use Serapium's op macro for making a quick local definition, because then I can specify. Because the problem is that compose doesn't know the number of arguments that each function takes, right? And same with Alexandria's curry. They both have this problem. They don't know how many arguments the functions take, and so they have to use apply all over the place, and it ends up being a mess.
But couldn't you find you can inspect the function that's being passed in?
Not portably.
Man.
Not portably.
Interesting. Okay. So if you really wanted to generate a point-free base style like function that takes in one argument and goes through and passes into the next, there's no real clear way of doing it. Efficient way of doing it inside Common Lisp.
Not without macros.
Not without macros. Okay.
Yep, which is why I generally use
Serapium's
op macro. Yeah, which is basically just a shorthand for Lambda, but it's a really nice shorthand, so it gets the job done.
So let me. Oh, I should have popped out. Hold on. How do I get back in?
Comma GB.
Wait, comma.
You can just hit comma GB anywhere, and it'll pop you back to where you were.
Ah, excellent. Okay, so since I have Serapium in here, I may as well see what.
S:op.
Hold on. Let me quit out of this. And 1 second. I'm gonna close this guy down so we actually have only 2 windows. Okay. S:op. Okay.
Yep.
And comma GG.
No, don't look at the definition of that. No, that thing's a mess.
Ugh.
No. I do not recommend you look into that. That thing is a mess. No. not recommending that.
I'm gonna
I've read it. It's actually very clean code if you know what it's trying to pull off. But It's a lot of macro magic, and you just kind of have to deal with it because it's a bit of a mess. But it's actually really easy to use. That's why I like it. I can explain the usage very quickly.
Okay.
Rama, you know Clojure's hash syntax is a shorthand for a lambda, right? You can do hash paren and then give like
Yes.
an expression as percent signs.
Yes.
Op is basically that, but underscores instead of percent signs.
Oh, cool.
So you can do s op, and then you give an expression, and anywhere that expression includes underscores, those become the arguments to the lambda. In the left to right ordering of the underscores, or you can do underscore and a number and specify which argument you want.
So
I believe you can also do underscore star for all arguments.
Yep, that gives a rest arg.
Ooh, okay. So if I do underscore, I gotta think of something now. I'll just do a square. So this simple dumb function will make this a single argument function here?
No, we need S1, underscore 1, underscore 1, if you want that.
Okay.
Because the two underscores will become two separate arguments otherwise.
Okay, so can I use this? Okay, so this is XY. So if I ended up, can I assign this to in a let form, like?
Yeah, it's just a lambda expression at that point.
Okay, so
you can't use it at the head of a list to call it directly because you can't extend that syntax.
Right. So let me see, molt, and let's go back. Okay, this is a let. There we go.
No, your parens are a little off.
Am I?
Well, put the point before print.
Yep.
Put the what now before print?
Put it before print.
Yep.
No, before print and hit.
Oh, before print. Got it. Okay.
Space KB. Before
KB.
print. I don't know if that'll do it.
Yes.
Oh, that'll do it. Okay, good.
Yeah, now that's what you wanted.
What? Molt is not defined. I just defined it.
Oh, no.
You got to fun call it.
Oh,
Yeah.
fun call it. Okay, so it's fun callable. Okay, got it.
Yeah, well, because you aren't making a local function binding. You're just making a variable that contains it.
Right. Okay. That worked. Alright,
Yeah.
at least it looks like it worked. I'll go over here. There it is.
Yep.
Cool. That's really cool.
Yeah, I use that for just about all my lambdas these days.
Interesting. Well, figured that we're going to hit. This will take a little bit longer than I thought. We just hit our 1.5 hour mark here. You guys want to go through? You guys have time to go through Macrolet?
I mean, I can be here for a little while yet, but I don't want to keep anybody else on.
Yeah, I mean, if you want to go through it, go for it. I'm good.
All right, because I think this topic, because this leads right into Macrolet. So I have to go and find that example from. He basically writes in his book nlet detailed recursive stuff for nlet, like we tried to do last time, but he uses Macrolet here.
Yeah, Macrolet's probably the easiest way to do it.
And so let me go and pull up the example that he wrote, and then I'm just going to go and adjust it very quickly.
Wait a second. We didn't even finish tree leaves.
Oh, that's right. We did not finish tree leaves. Give me a second. Let me go and pull up the example that you had.
Yeah, because what we have so far is pretty useless as far as I'm concerned.
Yes, it is very useless. You have a very good point. Okay. So, clearly, Tree Leaves has its stance right now. Doesn't do much. It has, Michael pointed out, it is pretty useless. It just changes some stuff. What we really want is a transforming tree leaf function that visits through each leaf of our tree, and then apply some sort of function to that leaf. If it, matches some particular predicate. Like if it's, in the case of the example that was presented in the book, he used, if it's even, do some sort of transformation and filter it out, if I'm not mistaken. Otherwise, just leave it alone. So the way you can do this is simply pretty simple. It's just the same recursive function. We can actually apply this function in this func callable form and apply a func call to each leaf based on this test function that's passed in. Okay, so how does this kind of work? Let me go ahead and compile this function. Thanks, Michael Fiano, for actually writing this implementation. If we just simply replace what we had before with tree leaves, and we pass in a lambda that takes in a value, let's say, and we return the square of the value, and actually the first argument is test, right? I think that's test. Let's go and double check here. Yeah, the first lambda is our test function. We're going to check to see if it's a number and it's even. And if it is, we're going to square it. Yeah. What this should do is it's going to go through, find all the even numbers in this tree, square it, and return that value. Otherwise, what it's going to do is it's going to just return the normal value that was originally inserted into the tree. So let's see how this works. As you can see here, it recursively adds this this value to it recursively walks through the tree, finds the even numbers, and then just simply applies that second function to the tree. So this is kind of nice, but we can also do something that's interesting, because this is a generic kind of structure, okay? You'll be applying this for many different types of code walkers, right? So what Doug did is he created a macro out of this, which I don't think it's necessarily needed, but I'm gonna go ahead and show it to you guys as it stands. This way, we're complete. All he did is we need one more function here, which is we take the stuff that we have here. Okay, we're going to make a function called tree double double, which I think is just simply this guy. We're going to rename Michael's function here to tree double double, which I think is the original implementation. Yeah, it is, for the next step. Then what we'll do is we're going to create a macro, def macro, tree leaves. Jeez. Leaves. That takes in the same arguments, and it will call our function tree leaves double double. And let me just make sure I actually compile that. And what this does is we're going to simply just call we're going to generate this lambda function that you see here, so that the code can always just have the actual executable pieces as being part of the block. Now, this is just taking some of the boilerplate out of the equation, which is what sometimes is useful for actually sorry, I need to first go into insert mode. For adding like things like error checking in functions and forcing people to like be consistent in the style, and more importantly making your code look more like a specification in some cases. So what I'm doing here is I'm just simply, and this is straight from I think this declare ignore x, right? Yeah. In SBCL or in the common Lisp standard, ignoring a value is simply ignore uh, ignore x, isn't it? Michael, Elijah, hello.
We're still here.
Yes.
And
Okay.
yeah, that's correct.
All right, cool. Because I know he uses ignorable, and I've never seen ignorable before.
Oh, yeah. So ignorable is if you don't know for certain if a variable is going to be referenced, which happens in the case where you have user code that may be touching the variable, but you don't know that it will
You don't
be
need it
that
in that
variable.
So you don't need it in what now?
You don't need it there.
It could be used in this case, right? So if I use it here, I just hold on. Oh right, I have to unintern tree leaves since I defined it as a function before.
No, you don't. No, you don't. Just compile it again.
Yep.
It just says
It's
caught
warning.
style warning. Oh,
Yeah.
okay.
It's emitted the style warning, but it still did it.
Oh, okay.
If it admitted like an actual warning or an error, then it might not have actually done it. But if it was just a style warning, it
So
probably it actually did it.
So what you're gonna see here is, and this is why he brought up this concept of implicit context. Is this is how his ultimate code looks like for this, and even number. So what? The function is not a 5. I'm using it as a function, aren't I? I can't do this.
That should have been valid. That's weird.
You got an extra paren on the end of that.
Yeah, well, oh, I do. No,
No,
that's
you don't.
right.
Not anymore because you
No, you don't.
passed that opening paren on that line.
Yeah, if I do this and then do, space K unslurp, I thought it's what I need to do.
Unwrap.
Unwrap, sorry. Space K
Capital
shift
W?
Yeah, capital W, yeah.
You should still be able to print that though. I don't know why you wouldn't.
Let me take this guy to the REPL. Tree leaves is undefined. It's not undefined. I defined it. Okay. This is why I sometimes just unintern.
No. You shouldn't be bothering with that. There's something much more weird going on here. Go up to the top of your buffer. Yeah. Hit comma SS for me.
Okay.
Okay.
Now try it.
Type in tree leaves in the REPL.
Okay.
In parentheses. Just to see what happens.
Yeah, hit space, yeah.
Nothing.
Nothing.
That's weird.
Describe. Actually, describe won't work since it's a macro, but.
Just do all symbols.
Yeah. I guess, yeah. Well, the symbol it definitely exists because we're using it. So do all symbols will see it.
Dual symbols var.
It's a do macro.
Oh, never mind.
Yeah,
Forget that.
but dual symbols will see it because we're using the symbol, so it's in turn. No, what's weird? Okay, go back to the bottom of the buffer again. Okay. Compile that, comma cf.
Oh, I see. Hold on, never mind. I know what the problem is. That's why.
Oh, yes. Yeah. That's the problem. You're right. That would have taken a bit longer to diagnose.
So it does what it does. But the reason why in this code example that he did this ignorable, which is why I'm bringing it up, is he created essentially implicit variables, and this is actually an introduction to what we'll be discussing further in chapter 6 in a couple in next week, which is the fact that we introduce a variable without it being visible, which means we kind of violated lexical transparency. But apparently, this is an example of an anaphoric variable.
No.
Depends who you ask.
Another way this is straight from his book. Another way to say in this example for tree leaves is that an anaphor named X is introduced for those forms to make use of.
Yep.
Okay. I mean,
yeah. Strictly speaking, in order to call it an anaphor, it needs to be named it. But okay. We're not English majors, so.
Okay.
So I actually think that this macro is a bad idea. I think it's over abstracting it, because now what if you had a list of trees and you wanted to map car over them to change, each tree? Now you can't do that because it's a macro.
Right. I think he did over architect it a bit, and it's a contrived example, but it does show this particular use case. Although I still believe that looking at the code, that between this version and this version to me is more understandable. This one, I have no idea. That is from line 81 through 84. I have no idea what exactly this is being passed into and what exactly this is being passed to. I mean, I can look I'm looking in the signature, but this doesn't tell me anything because it's not an anonymous function, right? It's just a form. Is it going to be used as a conditional? Is it going to be used? I have to go and expand the actual macro to figure out what is going on. Which,
I mean, that's what documentation's for.
Yeah. But yeah.
Not that the Lisp community is particularly good at documentation, but that's beside the point.
We're not going down that route. I think that at some point some of these techniques should be probably written up somehow and then posted somewhere. But again, that use of anaphor was not me saying that's an anaphor. It's straight up from the book. So.
Well, I mean, any macro that introduces a variable that the user didn't provide.
Yeah.
There's always been a decent fraction of the Lisp community, and for a long time, myself included, and I'm still kind of on the fence about it, that describe all of those as anaphoric macros. It's a convenient shorthand, even if it's not entirely accurate.
But to you, to make it a true anaphoric macro, I have to make this into it.
Needs to be it. Yes.
So.
It's me being pedantic when I say that, but,
So I have to say this is it. Okay.
Mm-hmm.
And now I have to, okay, first off, let me just correct this. compile it, and then here in my use, I have to say it.
Yep. Yep. And now, strictly speaking, I would call that an anaphoric macro.
Well, it doesn't have to be specifically it. It could be any anaphor, like this or that.
True. But the symbol needs to be an anaphor.
Anaphor is a linguistic term, so.
Yeah.
Right. Okay. Yeah, I'm not a linguist. I only play one on TV. No. So. Okay. Well.
I'm a Loge minutes. Does that count?
What?
Nothing. Ignore me.
Okay. So, I think we'll end today on this note because this is the code walking with macrolet is a fairly involved example, and I really want to put some emphasis on that example as well as the later section on D Lambda too as well. So tune us in for next week when we talk about complete chapter 5, and hopefully time permitting we'll start chapter 6 on anaphoric macros, which is starting the cool advanced Lisp tutorial that this book really,
Chapter 6 is by far the best out of any chapter. You get into P lambda and all that weird stuff.
Yeah, so we might end up spending a couple, I mean, depending upon how difficult the examples are. I'd like us to try compiling a couple of examples, just to, bring it in, because I know when I was looking at that chapter, it was I was like, okay, I need to really work through it.
More than a bit brain bending.
Yeah, it's a little crazy, but
perhaps mind expanding.
Now, before we leave, I just wanted to mention to folks who are on this channel and watching, as well as anybody who watches this recording later on, that I am looking for suggestions for topics to discuss. I'm on Discord, so feel free to ping me on Discord. I'm Bugram on Discord. I'm also on the Functional Programming Slack channel. Just write a message in there saying that I have an idea for a talk. If you guys are wanting to give talks, let me know also through those channels as well. As you all know, our stuff is on YouTube. So feel free to look at those, and if you guys have questions on some particular project ideas and stuff, I honestly would like folks who have done their games to show off some of their games in our study group, especially if they were done in Common Lisp, Clojure and stuff. I'm in the process of thinking about how to start up a Clojure channel, a Clojure study group, to go through it more, but that's just time permitting. But if you guys have project demos and stuff that you guys want to show up, please let me know, and we can give some time to go through them. But any other comments? Did the Game Jam winners get posted, Michael?
Yes, they did. Yeah.
All right. So
Technoman came in first place. He actually came in first place last year too. He's a pretty good game developer. So a lot of good submissions this year though. A lot of new folks showed up. A lot of old folks showed up. Everybody did better than they did last year, so it was a success.
Well, I think we should do some more of those. There's the fall jam too, right? Is that not? That's still up in the air.
That was just sort of like we did it a couple times. I think going forward, we talked about this, a couple of the regulars. We're going to do in the spring jam. We're going to have a Common Lisp game jam, hosted on its own platform instead of itch, because a lot of people gave their complaints about itch, and there's just a lot of game developers in Common Lisp, so they all want their own dedicated game jam. So I think in the fall we're just going to do the normal Lisp game jam.
Okay, cool. All right. There you go. You heard it, folks. We're going to have some more planning. And again, post our talks and talk updates on those channels, functional programming Slack or Discord. So I'll see you guys next week. I'll see you later.
Bye then.